Hello everyone. In this section of finding volumes, our volumes are going to be created in a little bit of a different way than just rotating a little area about the x or y axis. Here is what's called the cross-section method. And here's just a little picture. Sometimes in the problems I'm going to give you will already have the pictures drawn. Sometimes it's drawing the pictures. That could be the hardest part. But the the volumes or the solids are created by having a series of like little slices show up, but again, the slices are not generated by revolving anything, they're just cross sections. So I just want to show you a little animation here to maybe make it a little bit easier to picture this. So imagine we just have a circle graphed here. Again, we're laying down the x and y axes, and all of these, if you look at all of these little lines, they are perpendicular to the x-axis, and those are going to be some clues in our problem, just to give us direction on which way these slices are coming up. So I always like to consider, like if we go to lay this down, it's like looking at a floor. And imagine like a series of squares or circles, it could even be triangles, are just coming up through the floor, but they're so close together and there's so many of them that a solid is created. So I just want to take you through. What you see right now is just one cross section, and this cross section happens to be a square. So I'd like to say, like, imagine like this came up through the floor here. We have like a little opening and it's just kind of rising up here. And you're going to see that for each different x value, the squares are going to be different sizes. And then at the end of the animation, you're going to see all the squares together at once forming this solid. So this is just taking you through, showing you the different sizes as the x values change. Just to show you one more time from the very beginning of the circle to the other side. And then here's all the squares staying there, all the cross sections staying there. You could see how this is forming a solid. And I'll show you one more time, and then keep the solid there. So now this is the solid, and how we find the volume is we take the area of each cross section and we add it together, and then we'll get the volume. All right, so I'm going to start to take a look on page 390. If you have your books with you, you could look at this. There's parts A through D. A and B have the pictures already graphed for you. The homework problems I'm going to give you are only going to be two. They will have the pictures of the cross sections already drawn in for you, so you don't have to worry about doing this. And you're going to see my nice handiwork when I go to sketch for C and D. All right, I want to just read you the problem here. This is saying the solid lies between planes perpendicular to the x-axis at x equals 0 and x equals 4. So if you notice, we're looking at x equals 0 to x equals 4. All those cross sections are just being drawn in here. Notice how the x and y axes, like the coordinate plane, is just kind of laying down like it's on the floor. Cross sections perpendicular to the x-axis between these planes run from y equals negative radical x to y equals radical x. So that's the curve here, meaning it's just a sideways parabola. So it's showing you here, even though it's giving us that y is equal to the square root of x, we could also say that x is equal to y squared, and that's what they have drawn in down here. So what we're looking at is that this is y is equal to the positive square root of x right here, and then the negative square root of x is what the problem was telling us it's running to. All right, so notice here it says cross sections are circular disc with diameters in the xy plane. So here's a diameter, and then notice we see the circle. So imagine, even though they only have 3 drawn in, imagine just a series of these infinite amount of circles kind of packed together to give us this nice solid, which almost looks like a bowl sideways a little bit. So here we just, again, want to go the slices. We want to write out the slices are circles. So all we have to do is find the area of how to represent the area of each circle here. Well, the diameter goes all the way across. I'm only concerned with the radius, which would be right here. And then that, again, is just going to the y value. So that is equal to just the square root of x. So y is equal to the square root of x. I'm actually just going to write it this way. So the area of each slice is going to be pi r squared, which becomes pi times the square root of x squared, which just becomes pi times x. So now my volume is going to be the integral running from x equals 0 to x equals 4. Again, I'm going to keep the pi on the outside. So 0 to 4 of just x dx. So all I'm doing is I'm adding up all of the areas of all the slices here. And as you've seen in the past problems, that the integrals we set up are not too complicated. So we could just say pi times x squared over 2 from x equals 0 to x equals 4. So then we'll get, just write it this way, pi times 16 over 2 will just give us 8, and then minus a 0. So we get 8 pi cubic units. Alright, so again, toughest part is just trying to figure out how to set up the area. If the picture's already drawn for us, that's a nice bonus. Other times we have to draw this out. So let's take a look at 2b. This was just the picture I captured, just so you guys could see this from the animation. Alright, 2b. Here the cross sections are squares whose base is in the xy plane. Sometimes it could be a diagonal, sometimes it could be a base. As we saw with the circles, it was the diameter that was right on the xy plane. So here we have a square. So trying to figure out, again, we have to go with the area of the square. So the slices are squares. Now the area, I'll just abbreviate, of a square is just side times side, so it's going to be side squared. But now we just have to figure out what is each side. So if I go to just the first square I'm looking at here, again, I know that this is the length of just radical x, because y is equal to positive radical x. Even though y is equal to negative radical x over here, it's just a distance, so I could say my sides, if I go to redraw my square down here, each side is actually 2 radical x units long. So my side squared becomes 2 radical x, this whole quantity squared, and I just get a 4x for my area. So now my volume, again, is just going from 0 to 4. I don't have a pi in this problem, only use pi with the area of a circle. So I just have the integral from 0 to 4 of 4x dx. So now this just becomes 4x squared over 2, or we could just say 2x from 0 to 4 of 2x squared. So then we're going to get 32, really minus a 0, so I'm going to get 32 cubic units. All right, now for C, it says the cross sections are squares again, but now they have their diagonals are in the XY plane. So I just recreated this myself, and what's going to happen here is if I have a section, I'm going to try to draw this as best I can. I'm not going to draw too many in here. All right, so what is right on the XY plane are the diagonals. So I actually have, I'm going to try to draw this in a different color. I have one side of the square here, another one here, and then looking at it here. So I have a square, but the diagonals are what is intersecting or in the XY plane. So I'm going to draw another one right here. And then another one right here. So again, I'm going to just sort of take out a square. And what I have to do is figure out this diagonal right here. That's really what is, if this is radical x, this is also radical x. So this is 2 radical x. So now I have to figure out what the sides of my squares are. So if I'm looking at a diagonal and I have a square, I actually have 2 45, 45, 90 triangles here. And if you remember, for special right triangles, so we'll say 45, 45, 90. Each leg we'll call it is x. And then the hypotenuse is x radical 2. So all I have to do is take this 2 radical x and divide it by radical 2 to get the length of a side here. So I'm just going to say that this is say 2 radical x over radical 2, rationalize here. So we're going to get 2 radical 2x over 2, so I just get a radical 2x for each side. So here, the area, again, is side squared. Each side is radical 2x units long. So this will give me the 2x here. So now my volume is the integral, again, from 0 to 4. I'll just have 2x dx, which just becomes x squared from 0 to 4, and I'll get 16 cubic units. All right, so again, a very important piece we had to remember here was trying to figure out how to go from the hypotenuse back to a leg. So to go from a leg to the hypotenuse, we take this value and multiply it by radical 2. So I had to do the opposite operation here. I had to take 2 radical x, and in this case, to make it easier, I rationalized it. So again, up here I get 2 times radical 2x. Down here I'll just get a 2, so those divide out, and I get radical 2x for the length of the side. All right, and then one more part for D. Again, we're still looking at the same curve. Here the cross sections are equilateral triangles with bases in the xy plane. So again, if I go to draw these lines that are perpendicular to the x-axis, I'm going to create equilateral triangles that are my cross sections. So again, I'm just going to remove one of these triangles. Let me draw that a little bit better. All right, so these are equilateral triangles. Again, the base right here, this is radical x on this side, radical x on this side, so this is 2 radical x. I have 2 radical x for each side. So now I need to figure out the height, because area of a triangle is 1/2 base times height. So now this becomes a 30, 60, 90 triangle. So 30, 60, 90. I now have my short leg, which will be over here. Let me erase this now because I'm not going the entire way. So right here, this is my short leg of this right triangle, so that's just going to be a radical x. So we have the short leg, the ratio here is going to be x. The height, or the longer leg, is x times radical 3, and then the hypotenuse is always double what my short leg is. So that's going to be the, we'll just say 2x. All right, so to get my height, I'm going to take the radical x and multiply it by radical 3. So my height is really a radical 3x. And then my area is 1/2 my base times my height. So I get 1/2, my base is radical x, my height is radical 3x. So I get 1/2 radical 3x squared. I could take the square root of this, so I just get 1/2 actually my base, not the x is right here. It's actually going to be 1/2 times 2 radical x, because that's my entire base, which is right here. So that's going to be times 2 radical x. So now the 1/2 times 2 is going to be gone, and I'm just left with radical 3x, which will just give me x radical 3. All right, so again, 1/2 my base, which is right here, is the entire 2 radical x. I have another radical x over here. So there's my base. My height, again, is radical 3x. Combining that, I get an area of x radical 3. So now my volume is going to be, again, the integral from 0 to 4. I'll just put the radical 3 on the outside, and then we can have x dx. So I get radical 3 times x squared over 2 from 0 to 4. So I get radical 3 16. So we're going to get 8 radical 3, because 4 squared over 2 is 8, and then we'll have a minus 0 after this. So we get 8 radical 3 cubic units. All right, so 4 examples here of now looking at cross sections coming up through a plane where the cross sections are going to be perpendicular more often than not to the x-axis. So I'm going to give you guys 2 problems, also give you a PDF of the pictures here. I just want you working on numbers 7 and 10. Like I said, they provide you with the pictures. 7 has 2 parts to it, 10 only has 1 question. But as you're working on this, either looking at the notes or working on the assignment, please let me know if you guys have any questions.